Hello guys, welcome to the lecture 5 of the chapter Polynomials. We have come so far in the chapter that we have finished exercise 2.2. Now we are moving to the next important topic of this chapter, that is division algorithm for polynomials. Guys, in this chapter, if I tell you, there are only three important topics guys. First topic is the basic topic, like the introduction topic of the chapter, that is like what is degree of a polynomial and what are the classification of polynomials based upon variable and based upon degree. What do you call a polynomial with highest degree of 3? Then you should answer that it's a cubic polynomial. Such questions might come. They might give you a polynomial and then they might ask you the degree of this polynomial and what is this type of polynomials called. That can be asked like a 1 marker question guys. And then comes the next topic in the chapter, that is a relation between the zeros of the polynomial and the coefficients, which might come for 3 marks guys. As you have seen in the previous lecture when we solved the exercise 2.2, there are two possible cases guys in that question as well. A question might come like they are given the equation and then they will tell you to find the zeros and then verify the zeros with the coefficient. That is one type of question guys, which we have seen in the first question of the exercise 2.2. And the second type which may come with that in that topic is that they may give you the zeros and then they may tell you to trace back the equation, that is to find the equation from the zeros, as we saw in the question 2 of the 2.2 exercise guys. These are the main important points guys. Make sure that you learn all of these. Now let's get into the topic guys. Now when you listen to the word division of polynomials, what comes to your mind guys? It's like dividing one polynomial with another polynomial. In your lower classes, in your primary classes, you must have come across division of numbers, and then in your upper primary classes, you must have come across things like division of algebra. Now we are going a step ahead from that guys. We are going to divide a polynomial with another polynomial. In general, in question, they will give you a polynomial with a higher degree and another polynomial with a relatively lower degree, and then they will tell you to divide the higher degree polynomial with the lower degree polynomial. For example, they may give you a polynomial as a dividend, a higher degree polynomial, like a polynomial with degree 4, and then they may give you a divisor with degree 3, 2 or 1. So let me get into the topic guys. So basically these are the basics guys which you have to remember. P of x is called as dividend, G of x is called as divisor, Q of x is called as quotient, and R of x is called as remainder. These are the four terminologies or nomenclature related to the division algorithm which you have to remember. P of x is dividend, Q of x is the quotient, and G of x is the divisor, and R of x is the divisor and the remainder. Now let's go ahead and see one example so that you understand it better guys. So let's start with an easy example guys. This is the first example under this topic. This example is also there in your NCERT textbook. We have to divide this polynomial by this polynomial. As I said you, the dividend polynomial, we'll call it as P of x. So this is P of x, and the divisor polynomial, we are going to call it as G of x. Now what we have to do is, we have to divide P of x by G of x to get Q of x and R of x. Let's go ahead guys, let's divide it. Put them into the places of dividend and the divisor. Now what you have to do is see the first term of the divisor and see the first term of the dividend. The first term of the dividend is 2x square, and see the first term of the divisor, that is x. Now in the quotient you have to write that number from which you are going to get this first term of dividend when you multiply the first term of the divisor. You have to find that number of quotient. The first term of the quotient which you are going to multiply with the first term of the divisor to get the first term of the dividend. Same as the case when you do for the numbers. The only difference is that here both numbers and the variable are together. It's easy, guys. So what multiplied with x gives us 2x square. So it is 2x into x which gives us 2x square. So the first term is 2x. X into 2x gives us 2x square. Now second step is, you shouldn't stop here, guys. 1 into 2x you have to do with the other term as well, which is present in the g of x. So 1 into 2x gives us plus 2x. Now as a simple division, like any other division proceeds, we are going to proceed the steps, guys. This becomes minus, this gets cut, and this becomes minus. If it is plus, we are going to write it as minus, guys. And if it is minus, we are going to write it as plus, guys. Here it's plus, so it's minus. Here it's plus, so it's minus. It gets cut, guys. It get cut. And then now 3x minus 2x is x. And this 1 is going to come down. So the remainder is x plus 1. No, it's not the remainder, guys. We can again proceed one step further, because here it's x plus 1 and even here it's x plus 1. So this into what gives us x plus 1? So this into 1 gives us x plus 1, because this itself is x plus 1. So here in the quotient, the next term after plus, you're going to get it as plus 1. So here it's x plus 1. Now when you minus it, you're going to get 0. So this is the quotient, guys, and this is, as these two have given in the question, that is the dividend and divisor, we found out the quotient and the remainder. In this case the remainder is 0, guys. This was a simple division of a polynomial. Now let's go ahead for another example. So now the example 2 which we are going to take under this topic is a bit lengthy or a bit complex than the earlier one, guys. Even this one is easy, guys. It is a cubic polynomial which they have given, which you have to divide by a quadratic polynomial. Here this is p of x and this is g of x. We have to find q of x and r of x. That's the whole meaning of division, guys, right? So let's go ahead. Let's first write it out. Which one is p of x and which one is g of x? So now let's start the division, guys. While I do the question, even you try to do it by yourself, guys, so that you'll get some confidence. 3x squared plus x cubed plus x squared. Oh, just a minute, guys. There's some error in the question which I noted down. Yeah, this one is 1, guys. The constant term is 1. So now this variable x, oh shit, x square into what in quotient, which term, first term in the quotient will give us 3x cube. Now we have to see x square multiplied by what first term in the quotient will give us 3x square. That is, what term in the quotient multiplied with x square is going to give us 3x square. So it is 3, since number 3 should come here. There's only one variable, there's no number, so 3 is obvious. And here it's x square and here it's x cube, which means it should be 3x, because 3x into x square gives us 3x cube. Since we want 3x cube to come here, we are going to multiply this x square with 3x. So the first term in the quotient is 3x. Multiplying it, we get 3x square, 3x cube, and then 2x multiplied by 3x gives us 6x square, and then 1 multiplied into 3x gives us plus 3x. Now alternative signs you have to change it, guys, alternatively. If it's plus, you have to make it minus. If it's minus, you have to make it plus. Since here everything is plus, we have to make it everything into minus. This is it, guys. Now here it is minus 5x square and here it is x square. So x square into multiplied by what gives us minus 5x square? It is x square multiplied by minus 5. gives us minus 5x square. And the second term is 2x. 2x into minus 5 is minus 10x. And then 1 multiplied by minus 5 gives us minus 5. Here you are going to change the signs as I said you. Then you will be getting 0, and here you will be getting as plus 9x, and here you will be getting as plus 10. Now if you see, the degree of here in this polynomial in remainder is 1 and here it is 2. So you have to stop the process, guys. When the degree in the remainder is less than the degree in the divisor, you can't divide it further, right? Because the divisor's degree is more than the degree of remainder. So this means this is the remainder, guys. So while dividing this, what we got to know is that this is the remainder, this is the quotient, and when this as a dividend and this as a divisor are given to us, guys. Now let's go and see one more example. This is a quite interesting question, guys, because this is not similar to the previous questions. It's a bit unique, and in your exam there is high chance that these type of questions may come. It's a bit tough than the previous questions which you have done, previous two questions which you have done under this topic, guys. In the previous two questions, they gave directly the two polynomials. You just have to divide it and find the remainder and the quotient. But here they didn't directly give you from which polynomial you are going to divide the given polynomial, but they are given in the form of two zeros of the polynomial, from which you have to first find the divisor from which you can divide this dividend, and then you are going to find the other two zeros. So the question here is, I'll move aside, you can note down the question or read the question once. Find all the zeros of this polynomial if you know that two of its zeros are this and this. So to find all the zeros, guys, first of all, the given polynomial is of degree 4, which means there are going to be 4 zeros for the polynomial at most. So when they're asking find the other zeros as well, I guess that there will be another 2 zeros because it's of degree 4, they're given the 2, so we have to find the other 2 zeros. So to find it, and as we know we are studying the topic of division, in your mind it might have come that this is going to be based upon division. So remember, guys, whenever this type of question comes in your exam, when they are given the 2 zeros of a biquadratic equation, degree 4, right, it's called as biquadratic equation. When they are given the 2 zeros, when you have to find the other 2 zeros, you will need the quotient after dividing it, guys. So by what you are going to divide it? Since they are given the 2 zeros, with this you can form an equation. That equation you are going to divide with this number with that equation, guys. First I'll tell you how to find that equation. As you know, these are the zeros. If you have seen in the previous steps, that is the the factorization step, in which you are going to split the middle term and find the zeros. Here they are given the zeros, we have to go in reverse, guys. They are given the 0, we have to go in reverse. That is, we have to write it like this, right? After this step you are going to get the zeros, right? Let's go in reverse direction. We have to go in the reverse direction. We'll write these two first. Now this is the equation, guys. Is this the equation? Yeah. When you open it up, when you multiply it up and open the brackets, you're going to get an equation. Let's do it. You're going to multiply like this. This is going to get cancelled. This is the equation, guys. So with the given 2 zeros, we have got an equation. Now if you divide this polynomial p of x, so they didn't give the g of x directly. With the given zeros, we found the g of x. Now we are going to divide this polynomial p of x with this equation g of x, and then we are going to get a quotient q of x. The quotient, we are then going to do factorization of the quotient to get the other 2 zeros, guys. Did you get it? I hope you are going to get it very soon, guys, when we proceed through the steps. So now this is the formula, guys. So this is nothing but a plus b and a minus b, right? So it's even directly you could have written that it's a square minus b square. A square minus b square is x square minus 2. Let's note it down at one side, guys. So let this be here. Now what you are going to do, you are going to divide this polynomial by this polynomial. Let's proceed with the division step. it's like the same previous steps, guys. Now you have come to the question like which we did the last two examples. Now you'll be able to do it, right, guys? I'll tell you, we'll do it now together. X square multiplied by what term give us 2x to the power 4. So here x square into what gives us 2x to the power 4. Since there is no number but here it's a number 2, we need 2, certainly we are going to need 2. So it's going to be 2x square, because x square into 2x square gives us 2x, x square into x square becomes x to the power 4. So it becomes 2x to the power 4. So here it is 2x square. So it becomes 2x to the power 4. Now we are going to multiply the second term with the quotient's first term, minus 4x to the power 2. Now if you see, the cube term doesn't exist, right? So just leave a gap here. That's it. So this is the remainder of the second step, guys. Now we are going to further divide it. So x square into what gives us minus 3x cube. So it is minus 3x. Minus 3x into x square gives us minus 3x cube. Now you have to just multiply the second term of the divisor with the second term of the quotient. So x square minus 2. Now if you see, x square minus 2. Now if you see, this and this both are exactly same, guys. So with what number you will multiply to get the same number? You are going to multiply by 1. So it is plus 1. If you multiply x square minus 2 into plus 1, you are going to get the same number, x square minus 2. That's what we exactly want to get it cancelled. Right. So at the remainder you got 0. So this is the step we have to stop. Now the two zeros, with the two zeros we found the g of q and then we found the quotient now. Now with this quotient, with the help of splitting the middle term or the factorization method, we can get the other two zeros which they are asked in the question. Now let's go ahead and find the other two zeros, guys. Let's do the factorization here. Here itself I'll do it. By splitting the middle term. So after splitting the middle term and finding the factorization of the quotient polynomial, we got the other two zeros as half and 1. So they have said you to find all the zeros of the polynomial. In the given question itself they gave two zeros. So in the answer finally you will conclude by giving all the 4 zeros of the polynomial, guys. That is root 2, minus root 2, half and 1 are the 4 zeros of the given polynomial. By this you are going to end the question and you are going to get the 4 mark, guys, if you have done all the steps step by step. And in between the step also do write it in the braces in the right side that what are the steps you are doing. For example, when you are doing this division, before doing the division you can add a heading like dividing p of q with g of q to find q of x. We are going to divide p of x by g of x to find q of x. And then when you're factorizing it, you can write it as factorizing as a small heading so that it will be easy for your teacher to correct, so that it also increase the neatness and organization of the answer. That's it, guys. These are, you can take a screenshot and move aside now. So that's it, guys. Now we saw 2 examples of a normal thing, that's the easier one, that's p of x by g of x, and we also saw one which is a bit trickier, that also we solved. Now we are ready to start solving exercise 2.3 that is completely based upon the division. It has a question like the example 1 and 2, and also it has a question like this things. When you are doing those questions, which I'll be doing it will be, I hope that you'll get the concepts even more clear. So that's it, guys. That's it for this lecture. In the next lecture we'll meet with then exercise 2.3. Bye, guys.